Okay, so here we have a geometry question, and we're trying to figure out, so this is HL over JL, which is equal to IL over KL is also equal to what ratio? And for the next question, it says if triangle HLI is similar to triangle JLK by SSS similarity theorem, then HL over JL is equal to IL over KL is also equal to what ratio? Okay, so let's try to draw this triangle. Okay, so they're saying that we have two triangles, which is triangle HLI, which is similar to triangle JLK. And first of all, when two triangles are similar to one another, right, that means the sides are going to be equal, right? Or proportional. Sorry, not equal, but proportional, right? So when we have something that's proportional, right, it just so happened that the way they drew the two triangles, right? They look like the dimensions are similar, right? But the whole point of similarity theorem is the sides are proportional, so they're not necessarily equal, right? So if you have HLI, so they had, okay, so apparently the second triangle is HLI, but I'm going to write that as the first triangle. So we have H and you have L and this is I, and then you have JLK rather. So yeah, just by looking at the figure, when two triangles have proportional sides, they're not saying that they're congruent or they're not equal to one another. It's proportional. So the proportionality is different from two triangles being congruent. Okay, so I just wanted to put that out there. So if you have JLK, okay, so that's the pink triangle that they have here. Yeah, I just wanted to have the first triangle being HLI just because I think it's reasonable to have this statement and you have the first triangle being HLI. So, okay, great. So now they're trying to say that you have HL over JL. So as you can see, HL is over here and you have JL, which is over here. So here's the thing, when you're trying to write up a proportionality theorem, so it's a ratio, right? You need to have the two sides that are proportional. So say for example, you're looking at HL, right? So you have this HL over here. You're going to say that this, right, is going to be proportional to the other triangle, right? So you're supposed to have the numerator, right, from one triangle, right? So that's one segment, and then the other one would be JL, which is coming from the other triangle. And this is going to be equal to IL, which is right here, and you have KL, which is right here. So it's really important to split up your triangles, right, into two equations, right? Or two fractions, rather. So one triangle is coming from this segment, and then the other side, right? So we said we had HL, so the other side was IL, so that's for another fraction, if that makes if that makes sense. So you have IL and this is over KL. Okay, so this is going to be equal to what ratio, right? Because it's the SSS theorem, right? So you're saying that all of the three sides of your triangle are proportional, right? That's why they need to come up with, let's see what they wrote. Yeah, so they need to come up with another side of the triangle, right? So because they're saying that you have this HL and you have this over here, so you need to have your IH or HI and this KJ over or JK rather. So it's up to you whether you're trying to name this as IH, right? Just make sure it's consistent. If you read it as IH, it has to be KJ. And if you read it as HI, it has to be JK. So based on this SSS theorem, you can say that this should be equal to HI, right? So, and how do I know the numerator needs to be HI? Well, you're referring to triangle 1, right? So I'm saying that HLI is your triangle 1, right? So as you can see, your numerator all of your segments, right, or sides of your triangle are coming from triangle 1. So you need to be consistent. So that's how you write your proportionality ratio, right? So if you have HL to begin with, you have IL over here. So now you know that your numerator needs to be coming from your triangle 1. Does that make sense? And then, because you're saying it's HI, then you need to read this as JK over here. So all of your denominator from this point to this point, right? They're coming from triangle 2. Okay, so hopefully that was clear because this is the SSS theorem, so that's why it has to be sides, right? We're not looking at angles here. Because being proportional, right, for the 3 sides, because it's SSS, it doesn't mean that your angles, right, all of this angles inside, they're going to be exactly the same, right? However, because it's based on the SSS theorem, right, you can say that this angle L is going to be congruent to the other angle over here, right? Does that make sense? Because they're similar, right? But you cannot say that based on the SSS theorem, all of this, or in other words, you're going to say that this is an equilateral triangle, right? You cannot say that. You can only say that this angle would be congruent to the other angle. Over here, this angle is going to be congruent to this other angle K, and this angle H is going to be congruent to this angle J. So that's all you can say for SSS. But yeah, but the whole point of this question is not to say that the angles are going to be congruent. It's just looking for the other ratio. Great. So let's see what they wrote. Okay, so this is what I said. Remember, you have angle H, which is congruent to angle J, so that's right. You have angle L, which is congruent to angle L. It just so happened that this is also angle L, but it doesn't necessarily need to be the same letter, okay? So it could be, this could be P, right? It doesn't have to be the same letter. It just happened coincidentally that they're both L. So this and this needs to be congruent, right? And you can say that I and K, they're also congruent. So yeah, that's it. That's basically right. So the two of these answers basically are right. So I have nothing to correct. So this is perfect. Okay, great. I think we can move on to the next question. Solution is correct.